Alright, welcome back to our video series on setting up and securing CentOS servers, and our particular use for this server is going to be a node on the Ripple network. This guide is good for basically any kind of server that you need to run on CentOS. So in this guide we're going to look at setting up some SSH keys and securing SSH. We're going to be also following along with the written guide on the rabbitkick.club website, so I'm going to go ahead and bring that over here. So the first thing we're going to need to do is go to a terminal window on our laptop there. So if you see green over there, I'm using the terminal on my laptop, and use tmux to switch over here. If it's in white, I'm using the terminal on the remote server. So using the terminal on our laptop, I'm in my home directory. So I am going to list all of the files there. The -al flag just tells the ls command to list all files, including hidden files, and the L tells that we want permissions. So I'm going to see here, I do have an SSH directory already set up here, so I'm going to cd into that SSH directory. Alright, once I'm in there, I'm going to use this command to generate SSH keys. The type of key is RSA, and the B there tells it to make a 4096 rather than a 2048 bit key. So my email address, and so enter a file in which to save the key. We're just going to choose the default ID underscore RSA. That'll be just fine. It's going to ask us for a passphrase, so I'm going to make a new terminal window here, APG CLN, so that it contains capitals, letters, and numbers. Generate a secure random password there that we can use to encrypt our SSH key, and I'm going to just add that over here. And we'll take that and paste it in, and paste it a second time, and it gives us this random little art, and we now have some local SSH keys generated. Now that we've got our local SSH keys generated just on my laptop here, I can actually use rsync to upload my public key to the remote server. So here's the rsync command that we're going to use, and remember, always keep your private key private. Don't upload that to the remote server. So the rsync command is going to let us use SSH. That V flag is for verbose mode, Z uses compression. The E, SSH, says that we want to use rsync through SSH, and it needs the path here to my SSH key. I believe that that is actually correct. Let me double check that. CD. So we'll take this and change this to my username, which is rabbit on the remote server, which I have its IP address over here. And we'll go ahead and so this is going to upload my public key to the remote server, and I've got my username there, the IP address of the remote server, and it's going to save it in the home. My username is rabbit.ssh authorized keys file. Before I run that command, I'm going to go back over to the remote server though, because I remembered I need to create a .ssh directory probably on this file. So we're going to go into the home, rabbit, ls al, and we see there's not a SSH directory, so we're going to say mkdir.ssh. Okay, lsal. Again, notice by default that SSH is owned by root because I'm using the sudo I command, so I need to say chown, and we are going to change that to rabbit.ssh. And we also are going to want to tighten down the permissions probably on the SSH folder there. So you can see I've got, on the guide there, if you're having problems with SSH, we'll actually just go ahead and change the permissions here in a little bit. I just needed to change that, to the rabbit ownership so that I could get rsync to work. So we go over here, run our rsync command, and it's going to ask for my password, which is right there. and it was able to upload that key. So if we go back over to our terminal on the server there, we can now cd into the .ssh directory, do an ls, and we see we have the authorized keys file right there. So we can actually go over here and run these commands to make sure that everything is all kinds of happy in terms of permissions. And I already did this, but this time I added the -r flag there, so it'll actually also change the ownership of the authorized key file, which should be Rabbit because I uploaded it. And we can change the permissions as well. SSH is picky about file permissions. So we're going to go ahead and change those, and I'm going to replace the username with Rabbit and over here as well. The double and in the middle of the command there it basically just says only run the second command if the first one succeeds. So we didn't get an error message, both succeeded, and that is fantastic. This next command, the restoreconr command, when you're using CentOS, one thing to get used to is SE Linux. And this is a set of policies that basically limits what processes can access on the system. So for example, you wouldn't want your email server to access your .ssh directory. So SE Linux can limit like a web server, email server, or whatever it is from accessing directories, processes, things that it shouldn't have access to. We can actually use the ls-z specifier to be able to see the SE Linux policies. So you can see here that we've actually got an SE Linux policy on this that is SSH home. So that's going to actually let SSH access it. So it looks like the SE Linux policy came out good on this. And we're going to go back and ls-a again because it's a .file z. There's the .ssh directory, and again it's got that special SSH home specifier there. If it didn't have that, I would use this restorecon command to get that back there. And that basically just sets the SE Linux policy back to its default, for that that directory. If something isn't working on Cent, usually the reason is SE Linux, so that's something to definitely check out using that ls-Z specifier. So we've got our public key now set up, and so we are ready, I think, to go ahead and SSH in now using our key instead of our password. So I'm going to go ahead and exit out of this SSH session. So now I'm just back in my laptop, and so we've gone through, we've generated SSH keys for the laptop, a public and private key pair. The private key, of course, we keep private. The public key we've sent already up to the server using rsync there. And now we're going to go ahead and use this command to log in using our SSH key. So that is SSH, and the -i specifier tells SSH we want to use the key that we just made. So we're going to make it .ssh id-rsa. And notice I'm not using id-rsa.pub. I'm using my private key now to log in because the public key is up on the server there. And it's rabbit at, and we'll go get the IP address of the server. I need the password to decrypt the SSH key that I made as well because it's stored actually in an encrypted format. So we're going to get that and paste that in there, and I'm just going to go ahead and save that password. I wouldn't necessarily do that if this was a live machine, but I'm going to destroy it after the demo. So you can see we've now successfully logged in. It didn't ask us for a password. We'll just run that command one more time, and there you go. You see that we're logged in without having to provide a password. If it asks you for a password, something went awry with SSH, double check your ownership and permissions and that SE Linux to see what happened if we were asked for a password there. So now that we're logged into SSH using our private SSH key, we're going to go down and just change some settings in SSH to strengthen security. So as you can see, I'm logged in just as my regular user. I'm not logged in as a super user. Because I want to change some SSH settings, I'm going to actually run, again, the sudo I command. And so it's asking me for my username's password, which is right here. Paste that in, and I am now actually running basically as root. You can see that there. Now that I'm running as root, I can just type vim, etc., SSH, and SSHD config is the file that we're going to want to edit. So you're going to see a bunch of settings here for SSH. We're going to keep it running on port 22. If you want to enable more advanced security, look into port knocking. You'll set that up with IP tables rules. So you might have it running on a different port than 22 at that point. So you can change that there. I'm going to bind this to the internet IP address. Just paste that in there, and that is now bound. I'm actually not going to ever really use IP6 to log in, but I'm still going to go ahead and bind it to that interface, just so that someone can't, if they were to get access to the intranet, they couldn't come in and harass our server using SSH. So we're going to bind it to specific connections there. If you were using like a VPN or something like that, it would be a great idea to bind it specifically to the VPN tunnel and actually block SSH from incoming connections on SSH from the internet. Host key files, we're going to leave that as is, and you can see there's a list of settings we're going to change over here. While I'm up top, I'm actually going to go ahead and add in here to use protocol 2 and permit root login. We're going to say no. So no one can log into SSH as root. Allow users. And you can see these are turning brown. That's partially due to my vim rc configuration file, but on your text editor it'll likely change color to show you that the settings are valid. So we're going to allow the rabbit user. We've bound our listening addresses. I'm going to go down here, and just at the bottom you can see by default X11 forwarding is enabled. We're going to change this to no. We're not actually using the X11. It's a display interface, so we're just using the terminal here to interface, so we don't need that. Change this to no. We're not going to use that. We're actually not going to use Kuros either, which is already set to no. Challenge response authentication now. This is an important one. You're going to want to make sure to change password authentication to no as well, so that nobody can log in without using SSH keys. So we should have at this point, we also need I'm going to check one more thing. Ignore our hosts. So we've got this set up, according to the settings on the tutorial there. So we're going to go ahead, save this file. When you're in Vim, by the way, :WQ gets you, it writes the file and then quits out of it. You can look up Vim settings, if you're not familiar with that. So now that we've changed the settings in SSH, we're going to just run systemctl restart SSH to restart the SSH process, and by SSH I mean SSHD. Let's see. So it didn't like one of the settings that we changed. Let's look at that. That address or host. So it doesn't like the IP6 address that we put in there, so we need to edit that. And I'm guessing the reason that it didn't like it is because it does not need that. There we go. So SSH is happy again. We're going to log out just to make sure everything is looking good and that we can log back in. One thing that I like to do is to save my SSH keys actually just on an external USB drive that's fully encrypted. It's off the laptop. That way I need to plug that in, and you can set a custom path to SSH. Your keys if you did that. Now that we've logged in with the key though, and it knows the path and it's just in that default directory, we don't need to use that -i specifier, so we can now just say SSH rabbit at and the IP address of the machine to get logged in as the rabbit user. And we are back in. So our SSH settings worked and added a little bit extra security there, hopefully. So far in this guide, we've gone through disk encryption while choosing a server location, generating secure passwords, disk encryption. You've got root access using the sudo I command. We downloaded a default firewall IP table set and applied that. We've installed updates on the system, installed some basic software. I also go ahead and download a lot of times configuration files for Vim and for tmux, so that when I'm using them on the remote machine, they actually work as expected. I need to add a break there. Alright, so I've got those downloaded as well. So we've installed basic software. We've also, in this guide, secured the SSH connection. So now basically we've got a pretty secure machine set up, and we're ready to go ahead and install Ripple. So I will see you in the next video, and we'll go ahead and get Ripple installed.